What is left factoring? Left factoring basically, suppose we have this production S tends to alpha beta 1, alpha beta 2, alpha beta 3, and we want this string alpha omega tends to omega is equals to alpha beta 2. If we want this string, so what will happen with this grammar production? In this production, we have 3 alphas in the queue. So for the parser, for the compiler, it will always first get alpha, alpha, alpha in all the production. So it will difficult to find out beta 1, beta 2, beta 3. So in this kind of string, what is required? Elimination of left recursion. That is called left factored grammar. What we need elimination of left recursion, that is called left factored grammar. So what we need to do for this, what is the solution? Solution is S tends to alpha S dash. Now here we are taking a new variable, that is S dash, and S dash belongs to beta 1, either beta 2 or either beta 3. So these are the 3 production for this new variable, which is S dash. In that way we can eliminate the left recursion. So in that way, if it is LL1, if this is LL1 grammar for one length variable, here it is one length variable, and if it is LL2 grammar, then this is for 2 length variable. This is for 2 length variable. LL1 grammar, then this is for 1 length variable, and LL2 grammar for 2 length variable, and so on like that. If LLK grammar, then more number of variable come into the picture. This is depend upon the grammar, right? What kind of grammar we are exactly using. So in that way, we can remove the left factored grammar. S tends to alpha S dash, we take new variable S dash, and in this new variable we can go beta 1, either beta 2, either beta 3. So here the compiler will directly go to this beta 2, and we get this string alpha, which is omega is equals to alpha beta 2 after removing the left factored. So now let's take another example. Suppose we have S tends to A D A B, and here A tends to A oblique A B, and B tends to C C D oblique D D C. This is the grammar, and these are the production of the grammar. So how we are going to do this? Start from here, from S. What we do, we take S tends to A S dash, because here both are A's. So where to go, this is not decided. That's why we have to take we have to do left factoring of this grammar. So how we can do this? We can write A and S dash. We will take new variable S dash, and where S dash will go? S dash will go AD oblique B. AD oblique B. So in the similar way for the A also, how we are going to do this? First we are writing like this, A tends to, because here both are A in the left side, so A tends to A dash new variable, and where this new variable will go, A dash will be either epsilon, because here is a single A, that's why it will be either epsilon or it can be B. So these are the production, and in B there is no left factoring, so it will remain same, C C D oblique D D C. So this grammar become in this grammar there is no left factor, because we removed the left factoring by doing this pattern, by doing this method. So now in the next example, elimination of left factoring from the grammar. Suppose we have grammar S tends to A B A B C A B C D. Suppose we have this grammar and we need to remove the left factoring. Though how we are going to do this? We take S, and S goes to A S dash, because initially in every production we have A here, so there is a need to remove the A first, so that the compiler will not go in a loop, or it will not fighting for that the second string. So first S tends to A S dash. Now what is the S dash value? S dash will be, because here is single A, so it will be epsilon, or what else left? B. But here we can see clearly that after this string everywhere we have B, so there is another left factoring, so we have to remove this also. So how we are going to do this? We write here S dash. We are going to take the new variable, because after that compiler will fight all the B's strings, because all B's are there in all the production. So that's why we are taking the new variable S dash. So what will come in SS dash, because there is a single b, so first it will get the epsilon because there is a single b, and after that what we will get here? We will get here c, and we can see in both the strings c are present, so we have to take another variable, so that left factor will remove. So we will take SSS dash, triple S dash, new variable. So what will come in new variable triple S dash? The first is C is single here, so it will be epsilon, and what is left here? A, B, C are all over. What is left here? D. So in that way we can see in multiple steps. Here in this grammar we are removing the left factoring, not in a single way. In this grammar, in a single way we can remove the left factoring, but grammar can be of different type. So if the left factor is in the grammar multiple times, so after every step, if there is a left factor in the grammar, so we have to remove in every step, and we have to take the new variable for every step, so that there is no left factorable left, so that it will be easy for the compiler if we want any string. Suppose if we want A, B, C, D string, so for that compiler it has to fight for every production of that grammar. But if we do like this, if we make the variable for all the left factored in every step, then it will easy to understand the compiler, and it will give you the string in an easy way. So there is no left factoring left. So this is the way by which we can remove the left factor if a grammar is having left factor.